Hello friends, I hope you all are doing good. So in this lecture, I'll be discussing the second question of my second internal of data science examination. So the question says we have to give algorithm for all this machine learning model, which are data pre-processing, classification, clustering, decision tree, association, rule mining. So we'll see everyone one by one. So first, data processing. Data pre-processing is a crucial step in data science pipeline as it ensures that the raw data is transformed into a format suitable for analysis for machine learning. The algorithm or data pre-processing typically involves several steps depending on the nature of the data, which is numerical, categorical, text, etc. Below is a general algorithm that outlines the steps for pre-processing data. So the first step includes data collection, means gather the data from any sources such as databases, CSV files, web scraping, or APIs. Second is data inspection and initial exploration. Load the data into data frame or similar structure. So we have to load the data into Pandas library and basically you have to read the CSV file, inspect the first few rows using dot head, summary statistics with describe and data types with dot info. Identify the number of missing values, data types, outliers, and irrelevant features. The third is data cleaning, which is handling the missing data. For numerical columns, remove rows with missing values or impute missing values using mean, median mode. Second is for categorical columns, remove rows with missing values or impute with the most frequent values or placeholder. Third one is remove duplicates, drop duplicate row using drop.duplicates function, remove irrelevant features, drop features that do not provide useful information for your analysis of modeling. And the fourth step is data transformation, in which we create new features that may provide useful information. And then normalization for numerical column, scale the data so that it lies within a specific range, example min max scaling, or has a mean of 0 and a standard deviation of 1. The standardization can be done by subtracting mean and divided by standard deviation. And then normalization, and then encoding categorical data, convert categorical variables into numerical variables using techniques like label encoding, one hot encoding, ordinal encoding. And then date time conversion, convert date columns to a date time format and extract useful features, year, month, day, etc. Handling outliers, identifying outliers using methods like z-scores, iqr, or visualization. Depending on the nature of your model, you can remove outliers, cap or transfer extreme values, and then leave outliers as they may carry useful information for certain models. Data splitting is the next step. We basically split the data into two sets, training set and the test set. Typically 70-80% consists of training set and the remaining 20-25% consists of testing set. And then feature selection, dimensionality reduction, and then data balancing, and the final inspection and check. And then save pre-processed data, save the final pre-processed data to a new file, example CSV, Excel, for further analysis or use in training machine learning models. Now we'll see the algorithm for classification, which includes step for training and evaluation a classification model. The first step is almost same in every machine learning model, that is data collection, collect and load the data set. Second is data pre-processing, which we have already discussed, like handling the missing values, data imputation, scaling, splitting the data, model selection, choose a classification algorithm, example logistic regression, decision tree, random forest. And then the model training, train the model on the training data set. Then comes the model evaluation. We have to evaluate the performance of the test data set using metrics like accuracy, precision, recall. And then hyperparameter tuning. And then at last model deployment. Once satisfied with model performance, deploy it for making predictions on new data. Once you check that your machine is working fine, you can test the machine on the real data or on the data which you have to perform the operations. Now, the third one is clustering. Clustering is an unsupervised learning technique used to group similar data points into clusters. Here's a general algorithm for performing clustering. First step is same data collection. Second is data pre-processing, handling the missing values, feature, dimensionality reduction. Third is choose a Cluster algorithm. Select an appropriate cluster algorithm based on the nature of the data. K means most popular for partitioning data into K cluster. Basically, we select the number of clusters before. Second is hierarchical clusterings, build a hierarchy of cluster. Third is density based spatial clustering, useful for detecting arbitrary shaped clusters and handling outliers. Fourth is Gaussian mixture models, GMM, assumes data is generated from a mixture of several Gaussian distributions. Fourth one is determine the number of clusters if needed. So after selecting the appropriate algorithm, we have to determine the number of clusters if needed. For algorithm like K means we need to decide the number of clusters. This can be done by using the elbow method. Plot the sum of square distance for different values of k and look for an elbow in the plot. And then Celotti score, measure the quality of the cluster. The higher score indicates better clustering. And then the model training and then the model evaluation. And then at last we'll do the cluster interpretation, in which analyze a formed cluster to understand the characteristics of each cluster, explore the distribution of data points with each cluster and how they differ from other clusters. The last two steps are optional, which are post processing and deployment. Now, moving forward, the fourth one is decision tree. A decision tree is a supervised machine learning algorithm used for both classification and regression tasks. The idea is to split the dataset into subset based on the most significant feature recursively until the data in each subset are homogeneous. So the steps involved in the decision tree algorithm are, the first is say first, second, and the third step is almost same in every, the data collection, then data pre-processing, and then model initialization. Now, coming to the build the tree, start at the root node, evaluate the features to choose the best features to split on based on selection criteria, example Gini index, impurity, or entropy. So we basically select the root index by checking the entropy gain of the all particular columns or elements. And then recursive splitting, split the data based on the best feature, that is feature that gives the best split. Recursively repeat the process for each child node, splitting them further until a stopping condition is met. Example, max depth reached, minimum samples per leaf reached, no further information gain. The subsets at the leaf are pure, homogeneous, and class labels. Now, the fifth one is stopping criteria. The recursion stops when all the samples at the node belong to the same class. The tree reaches the maximum depth. The number of samples at a node is less than the minimum sample split or minimum samples leaf. No further improvement can be made based on the chosen splitting criteria. And then the next step is model evaluation. And then the last second step, pruning, which is optional. And then the model deployment. Once satisfied the model's performance, deploy the model for making prediction on unseen data. Now, coming to the last algorithm, which is association rule. So just wait. So the association rule mining is a technique used to find interesting relationship or patterns among a set of items in large data sets, typically for market-based basket analysis, where the goal is to identify items that frequently co-occur in transaction. The most common algorithm used in association rule mining is a priori algorithm, which is based on the principle that frequent item sets of items that occur together often can be used to generate association rules. The first two steps are always same, the data collection and data pre-processing. The third step is generate frequent item sets. The a priori algorithm uses the concept of frequent item sets to discover association rules. Step 1 is generate sets, count the frequency of each individual item in the data set, and then keep only those items that satisfy the minimum support. Step 2 is to generate K item sets. Use the frequent K1 item sets to generate candidate K item sets, that is, item sets that contain K items. For each candidate K item set, count its supports. Keep only those K item sets that satisfy the minimum support threshold. Now, the fourth is generate association rules. When the frequent item sets are found, the next step is to generate association rules from these item sets. Rule generation. For each frequent item sets, generate possible rules of the form A to B, where A and B are disjoint item sets. For each rule, calculate its confidence, which is the ratio of the support of the rule to the support of the antecedent left side. So the confidence from A to B will be defined as support of A union B divided by support of A. And then the minimum confidence threshold, only keep those rules that satisfy a predefined minimum confidence threshold. And then the fifth step is prune redundant rules, remove any rules that are redundant or less interesting. For example, rules where the consequent is a subset of the antecedent can be discarded. Now, coming to the evaluation of association rules, after generating the rule, evaluate them based on the support, confidence, and lift. So basically, we need to evaluate our association rule mining by the parameters that we have calculated, which is support, confidence, and lift, the fraction of transaction that contains the item set support, the likelihood that the consequent occur gives the antecedent, lift, the ratio of observed support to the expected support if A and B were independent. Lift can be calculated by P of A into P of B into A union B. High lift values indicate stronger associations. And the next last step is model deployment. If we get to know that our machine is working fine, we can use it on the other data as well. You can deploy them for practical use such as marketing strategies, product recommendations, or customer behavior analysis. So guys, this is all from the video. I hope you enjoyed the lecture. Thanks for watching. Bye.